What's up, year 7? Mr. Allen here, and today we're gonna finish the topic that we started last class, that we're talking about divisions, okay? So I have here two divisions, and I want you guys to pay attention and what is the big difference between those two, okay? So just to start, how many times the 5 fits inside the 2? Just an estimation, okay? I know that's gonna be around 2 point something, right? Because 2 times 2, 4. So 2 times 2, 4, I have some left, 1 left, correct? So I already know that it will be around 2. Cool? And how many times the 50 fits inside the 20? Okay? So let's do this calculation properly and see what's the big difference between them. Okay? So if I want to do here, how many times the 2 fits inside the 5? So the same way that you're doing that properly last class. 2 times how much equals 5? Better. How many times the 2 fits inside the 5? So far, 2 times, and 2 times 2, 4. 5 minus 4, 1. And now, as I have this rest here, as I have this reminder, I can what? I can write decimal point and 0, correct? So, bring down one number here, and I will have 10. How many times the 2 fits inside the 10? 5. Cool. 2 times 5, 10, and that's over. Nice. As I have my reminder 0. Don't forget the decimal point here, correct? So I got my answer as 2.5, correct? Let's write here that on the bottom, 2.5. Nice. So let's see the other one. If I'm gonna do 20 and 50 here. Nice. So how many times the 20 fits inside the 50? I know that's going to be around, if I do that, my times table from my 20. Because remember, every time that I'm doing a division, I need to know the timetables of my divisor. Cool? So how many times the 20 fits inside the 50? So far, 2. Again, I can get the 5 or I can get the whole 50 here. Okay, like we did last class. Mitch, I want to do step by step with the 5. Okay, so 5. Going to get on the 5. 0, 20 times 0. 0, reminder as a 5. Bring down the 0. As I bring down the 0, I have how many times the 20 fits inside the 50? It will fit 2 times. 20 times 2, 40. Then I will have 10. Okay? Now, 50 is the same thing as 50.0. So bring down a invisible 0. So I will have 100. 20, how many times the 20 fits inside the 100? Fit 5 times, 20 times 5, 100, then goes as a 0. And 50, I will have what? The decimal point just right here. Okay, so look at the cool part. I got the same answers. I got the same answers for 2 different questions, okay? And now, how can I relate those 2 questions? Should they have the same answer, right? So, I want to write this thing in a different way. You guys remember, when you're studying fractions, or better, what I told you guys last class, that all divisions are the same thing as a fraction, correct? So what do I know? I know that 5 over 2, that's the same thing that 5 divided by 2 is going to be equals to 2.5. Is that a proper way how to write? Yes, it is. Okay? And I know that 50 over 20 is the same thing as 2.52. Okay? Oh, I just forgot here to write my answer. 2.5. Nice. So, what is the relation that I have between my 5 over 2 and my 50 over 2? Oops, not 2. Everybody agree with me that I can do something like that. 50 over 20 is the same thing as 5 over 2, if I talk in terms of fractions, okay? And what is the big deal here? I know that they are the same division. If they are the same fraction, they are the same division, okay? Because what I did here, those fractions are equal. Yes. Why? Because I just divide here by 10 in the top, and by 10 in the bottom, and by 10 in the top, okay? So that's one of the ways that I can use my fractions to simplify my divisions, okay? Because if I have the same fractions, they must give me the same result in the same way that I did it here, okay? So how that thing will be useful for me, and that's where this thing gonna enter. That when you're gonna use then you're gonna do a calculation when my divisor is a decimal point. It has a decimal point because I don't know the timetable from a number that has decimal point, okay? So let's talk about that in the next in the Explorer, okay? So you guys can see the problem from page 149 written here, okay? So our problem is, Mark bought 19.5 meters of fabric to make costumes for a play. Each costume needs 2.6 meters of fabric. How many costumes can Mark make? Okay, so let's think about this problem. If I'm asking how many costumes that Mark can make, so I know that every costume is gonna use 2.6 meters of fabric, right? And I know that he bought 19.5 meters in total, correct? So what is my question here? I'm asking how many times the 2.6 fits inside the 19.5. So how can I figure out this question? Wasn't that the same question that I was doing every time when I'm doing a division, okay? So my question is, how many times the 2.6 fits inside the 19.5? So I'm asking to divide 19.5 for 2.6, okay? Can I do this kind of calculation? Yes, I can, okay? Now here comes the big trick. My big question is, remember every time what I used to ask, I need to know the times table of my number. I need to know the times table from my number here from my divisor to I do my calculation. But do I know the times table from 2.6? That's not so easy, right? If I don't know so easy the times table from 2.6, so I'm gonna transform this number here in a calculation that I know how to do, okay? So let's talk about it, cool? So everybody agreed that I can write this thing as 19.5 over 2.6, correct? But I don't want the bottom part with a decimal point, so what I'm gonna do? I'm gonna remove this decimal point. And if I'm gonna remove this decimal point, I need to multiply by 10 in the top, in the bottom, and multiply by 10 in the top, okay? Why am I gonna do something like that, mister? I don't want a greater numbers to work with, yes, but it's a must, because this way here, it's gonna get a simpler division. So it's gonna be 26, and here gonna be 195. Cool. So if I'm gonna do this part here, what's gonna be? Now, this calculation here, I'm gonna transform this in 195 divided by 26. Now I got in the same type of calculation that I was doing last class, correct? As I know how to do this one, so let's do it. So it's gonna be 26, 195, okay? So how many times the 26 fits inside the 195? I don't know, so let's do number by number like you did last class. 26, can I get the 1? Yes, I can, but it's gonna be 0, like I told you guys before. Can I get the 19? Yes, but it's gonna be 0, as I told you guys before. And this one is gonna be how much? Here, I can get with a 5. Let's check, okay? Or with 195. So here I know that it will be 0, because I can get. Here, I know that's gonna be 0, because I can't get either. But now 195, 26, how many times the 26 fits inside the 195? I don't know, because I don't know the times table from the 26, but I know how to get it, okay? So let's do our calculations here on the side. So 26 times 10 is too far, because it will be 260. But can I calculate 26 times 5? 26 times 5 is going to be equals to 130. Okay, getting better. So 26 times 5 is going to be equals to 130. So 26 times 6. Do I know this? Yes, I know this. 156. Then 26 times 7, it will be equals to how much? 26 times 7. If I don't know it, do the calculation. 156 plus 26. 12, 5, 7, 8, and here 1. 182. Okay. So 182. If I go one number greater. So here you have 80, but I already know that this number is going to be greater than 195. So here my answer will be 7. 26 times 7 is equals to 182. Okay, 5 minus 2, 3. 9 minus 8, 1. 1 minus 1, 0. Now what I'm going to do? Bring down the decimal point. Decimal point, 0. So bring down the 0. 130. look, my 130 here, okay? So I'll have a 5. 26 times 5 going to be equals to 130, and here the 0. Okay, so my answer is going to be 75? No, why not? Because here, my decimal point is going to be aligned with my decimal point in my dividend, okay? So what did I find out here? I find out that 195 divided by 26 is equals to 7.5. So if 195 divided by 26 equals to 7.5, it means that 19.5 divided by 2.6 is equals to 7.5 either. Okay? So I have two different calculations with the same result. Nice? But what is the big difference? I don't know the times table from 2.6. But I know the times table from 26. So that's why it's important that my divisor can never be a decimal point, okay? Cannot be a decimal number, okay? So that's why I always change. If I have a decimal, here's the rule for this class. Every time that I have a decimal point where in my divisor only, okay? In the dividend, doesn't matter because you did that last class. But every time that I have a decimal point in my divisor, what I'm going to do? I'm going to multiply that for something in order to remove the decimal point from my divisor. Okay? So that's a big deal for this one. So let's finish our question. It's asking, how many costumes can Mark make? Can he make 7.5 costumes? No. Or he do 7 costumes, or he will do 8 costumes. Okay? So if he's going to do 7 costumes, nice. So that was for my first question. And then how much material is left over? Great question. So it's gonna be left over only 0.5 meters? No. Pay attention on that. Okay? How many costumes that I can do? I can do 7 costumes. And 7 costumes, it's gonna cost me how much? Okay? I must do the calculation. So 2.6 times 7, it will be how much? If I know that 2.6 times 7, if I know that 26 times 7 is equals to 182, I know that 2.6 times 7, it will be something similar to that because the process is the same. But what I'm going to change here? Only my decimal point. So 18.2. Okay? So if I'm going to use for 7 costumes 18.2 meters, how much going to be left for the 19.5? So now I'm going to do a calculation. 19.5. Oops. So my calculation is going to be what? It's going to be 19.5 minus 18.2. And this calculation will be equals to 1.3 meters. Okay? So, guys, that's it about divisions with decimals, okay? I just want you guys to do another example that we're going to do that together in the Hangout, okay? So, try to do page 150, okay? The question from the Connect by yourself. So, page 150. The Connect. Try to do it by yourself, okay? Then you talk about this question in our Hangout. Nice? So I hope you guys understand. See you guys in the afternoon and bye-bye.